I'm a graduate student here at the University of Alaska. I'm also the collections manager at the Museum of the North on campus. So a team of us from the museum, we traveled to Denali National Park where we found a new site of dinosaur tracks. Dinosaur tracks have been only recently found in Denali, so we are just beginning to understand the extent of it. And they were only found around 2004, 2005. But now we're really realizing this is one of the largest track sites in the Arctic from the late Cretaceous, especially in Alaska. And we use a few methods of documenting, most notably photogrammetry. And we use small scale with using just handheld cameras, as well as using drones from the Aquasi Center at UAF, and to document the entire site. So here you have a 3D model from what the site is, with all the colors coordinating with large track-bearing horizons. This site in particular is also very important because it's got a bentonite layer near the base of it, so we can give a solid age to it, and we're getting dates of around 69.3 million years. Along with just the amount of data we're getting from the stratigraphy, biologically it is very significant with the amount of dinosaurs that we find here. Now, it's fairly hard to see, but these surfaces are covered with tracks, and we've been able to identify quite a few different taxa of dinosaur tracks, including hadrosaurs, what we see in Alaska, most commonly known from Agronala cookpacensis, which we have a few bone materials here at the booth, as well as smaller tyrannosaurs. And we have a little model here that shows the extent of a tyrannosaur footprint, which we can also use to determine the hip height of it. And by using the magic equation of multiplying the foot length by 4, that is roughly how big we're getting. And it's a tyrannosaur with a hip height over a meter in height. Now, yeah, we're finding new material every year, and yeah, that's just kind of the beginning of this site. So if there's any questions, I'd be happy to answer. Oh, yeah, the tracks themselves, so you're asking if they're on the surface, below the surface. The site is very convenient because it has been uplifted to about 70 degrees. And so all of these are essentially a giant wall. With that, we're getting all levels of preservation of the tracks, including subsurface under tracks, true tracks, which show detailed skin impressions, and natural cast, which is the underside of, or the infill of the track. So we are getting all levels of preservation there. Yeah. It's a very general, there is more, yes, so yeah, multiplying the foot length by 4, that is not the accurate one. There is plenty of calculus, but to go along with finding the true hip height. But it is a common trend within theropod dinosaurs that you can find that multiplying by 4 gives you a generalization of how big their hip height is.